already know that radicals are made up of an index and a radicand and sometimes a coefficient, right? And we talked about if we're going to add them, then the radicands must be the same, right? It goes back to algebra tiles. If you have 3 x bar tiles, you add them and you get 3 x's. So that's what we go back to here. So you notice we needed to have that and that and that and that to be the same to add them. Yeah? Everybody's cool with that, right? Okay. And we used the 3x plus 2x model to learn that it was 3 root 5 plus 2 root 5 gets me 7 root 5s. Everybody's cool to there, right? We're all on the same page, yeah? All right. Now. 8. So 5. Sorry. 5 root 5. To be perfectly honest, I probably looked closely at that 3 and saw it was a 5 in my head because my writing was bad, but who knows? Who cares? We're all on the same page. So, you're intelligent young people. This model works here. If I gave you 3x times 2x, what do you get? 6x squared. Because you multiply the coefficients, and then you multiply the variables, right? Now, what is it about the variables that allowed us to do that? They're the same base, right? If I had 3x plus 2y, what would the answer be? 6xy. Yeah? Okay. So putting all that together, we know that if we're going to multiply variables, if they're the same, we can do it no problem. If they're different, we can't. There's nothing we can do but list them. Okay? So what part of a radicand or a radical, what part of that would you say equates, and equate is a bad word because it's English, what part of that corresponds with the base of an exponent, do you think? Is it the x or the a? Some people are saying x, some people are saying a. Why do you think it's a, Eka?
Because the x is up there.
Okay, fair enough. So you're going on visual.
Yeah.
All right. Who said x? Why do you think it's x, Ken?
Because it determines how many times you
If, for example, this x was a 3 and I had a there, does that 3 tell me something about those 4 a's? It does, doesn't it? What? What does it tell me? What can I do with 3 of them? I can move them out. So, again, I ask, now that Ken has said his piece, what he thinks, and Ekam has said what he thinks, I'll ask everyone again, which do you think is corresponding to the base in an exponent, the x or the a? It's the x, isn't it? Because the x tells us how many, Mr. Friesen? Yeah, there's big trouble with that. You guys keep stealing it from me without telling me you're no, you didn't. But staff keeps coming in here and taking it, and just like with Betty, not saying when they put in the last one, they aren't telling me when they put in the last one. So I got an empty box there. There's none. It's coming soon. That's my fault. I should have known. The reason that I took it over was so this would not happen. But I've had too much on my mind lately. All right. So where was I? It's the x because that tells us how many, the group we can get out of there, right? So, you people being the intelligent young people that you are, when you have the same base, there's a law that works, yeah? If you don't have the same base, you just got to keep listing the variables, right? So logically, what would you expect 2 root 5 times 3 root 6 to be? Logically. 6 root 30. Logically. Because these are the same base, are they not? Because they're both the square root. Everybody cool? Now, of course, we would simplify if we could, but that's not what's important right now. What's important right now is understanding this. Now, what if I did this? 2 cube root 5 times 3 square root 6. What do you think that answer is? Six. Keep talking, Eckham. 6 cube root, but are these the same base?
No.
What did we have to do with them when it was different variables? We had to list them, right?
Yeah.
So what are we going to do here?
Cube root 5.
Cube root 5. Square root 6. Everybody cool? If they're not the same index, we're stuck. Everybody understand? If they are the same index, they just multiply. Like here. Easy peasy, right? So what's that first one going to be? Let's write it out the long way. Negative 7 times 5 root what? Yeah, 3 times 8. Everybody good? Which gets us negative 35 root 24. And then what would we do? Simplify, because that's 4 times 6, yeah? So we'd get negative 70 root 6, because we'd bring out the 2. Easy peasy, right? So simple. Nothing to worry about. What?
How do you get negative 70 root 6?
What's 35 times 2? You bring out the 2. What's 7 times 5? 7 times 5 is 35. 35 times 2 is 70. The 2 is right here. The square root of 4 is 2. 4 times 6 is 24. I know it's Monday morning, ladies and gentlemen, but... Well, okay, hold up. Hold up. There's no going forward if we don't remember how to simplify that. What is the square root of 12? 4 times 3, which is really 2 squared times 3, right? There's no number there, so I'm looking for groups of 2. So I bring out a 2 and I leave in a 3. Yeah? If there was a 5 out there, what would that 2 do with the 5? To get 10 root 3. Okay? Everybody's now back on the same page? Okay. Let's do that one. What do we get? 3 root 2 times 8, which is 3 root 16. What's the root of 16? So that comes out. What did I leave under there? Nothing. So what's the answer? 12. Everybody good? I'm a little worried right now. The square root of 16 is? 3 times 4 is? So the answer is 12. Is everybody okay? It was very quick to do square root of 16 times 3. Yeah, it takes using up a lot of the old brain power there. Burning a lot of brain juice on 3 times 4. Okay. I'm going to let you try this one. Everybody go. No, it's not FOIL. It's this. What do I do with the coefficients? Multiply them. -8 times 6. Root. What do I do with the radicands? 6 times 12. Now, I'm trying not to go too fast for everyone. What is 8 times 6? 48. But the 8 is negative. So what is it? What is 6 times 12? 72. What should we do now? Simplify. 72 breaks down into 36 times 2. Why did I use 36? Because it's got a perfect square. What is the perfect square root? So what comes out here? 6. What do 6 and 48 do? Multiply to get -288 root 2. Okay. Now, here I have 3 root 3 times 3, which is 3 root 9. What is the root of 9? 3, so it's 3 times 3, which is 9. Now I want to show you something here because this has a very useful little piece of knowledge. What happened when I did root of 3 times root of 3? What did I end up with? Root of 9, which is 3. So, if I have root x times root x, what is the answer? X. Right? Because it's the root of x times x, which is the root of x squared, which is x. Everybody understand? So what if I told you that I had the root of 29 and I needed to square it? What would the answer be? 29. Everybody cool? Okay. What if I had the cubed root of 29? What would I have to put there to get 29 there? A 3. I would have to cube the cube root of 29. Everybody cool? Everybody sees these patterns? Now, everybody always tells me they see that and they understand that, and then I ask them this.
Thank you. Took his car keys.
Times 2 cube root 4. Somebody always tells me this answer is 24. Why? Because they did 3 times 2, and they saw they had the same radicand. So they think that cube root of 4 times cube root of 4 equals 4. Because the square root of 4 times the square root of 4 equals 4. This is not true, is it? Because that is the cubed root of what? 16. Everybody understand? If I need to get rid of a cube root, I cannot multiply by the same thing. I have to multiply by 4 what? Squared. To get 4 times 4 squared to get the cubed root of 4 cubed. The cubed root of 4 cubed is 4. Does everybody see that? The problem that you people have is you lock this into your head. If you do radical anything times radical anything, you get the radicand. You lock that into your head without realizing that it only works for squareds. That's why I showed you this. You have to cube a cube. You got to get a cube root under there to have it come out. Levi. Yes, that would also work. So what Levi is saying is I have to get rid of a cube root of x. So he says he's going to multiply it by cube root x, cube root x. That's still going to be cube root x cubed, right? And you'd be fine. Everybody cool? All right. Now, start putting it all together. What would you do if it was just that? What would the answer be? 15 root 16, right? What would you do if it was just that? Plus 10 root 24. And what would you do if it was just that? Minus 5 root 40, correct? So, that's what you do here. You distribute. And then what do you do with those? What's the square root of 16? So what do I get here? 60. 24 breaks down into what? 4 and 6. Why 4? It's got a perfect square root. So what comes out? What was already out there? So what do I get? 20 root 6. What does that break down into? I would not use 8 and 5. What would I use? 4 and 10. Why 4 and 10? 4's got a square. What comes out? 2. What does that become? Minus 10 root 10. Is everybody good? Now, here we get to F. This is where I find out if you've been paying attention or if you've just been learning steps like trained monkeys. What are you going to do first with F? How many of you would go the cube root of 864? No, that would be silly. Why? Because that's a big-ass factor tree, isn't it? What should you do first? Simplify, simplify, simplify. When? At the beginning of the question. In the middle of the question. At the end of the question. Every chance you get. What is that? That's 8 times 2, right? Why'd I choose 8? It's a perfect cube. What's the cube root of 8? So isn't that 2 cube root 2? What's 54? You could use 6 and 9, but I would use 27 and 2. Why? 27 is a perfect cube. What's the cube root of it? Times 3 cube root what? 2. Easier to multiply, isn't it? What do I do with the 2 and the 3? Multiply them to get 6 cube root. What do I do with the 2 and the 2? To get what? 4. Heck of a lot easier than the factor tree of 864, isn't it? When should you simplify? Always. Everybody good? Yeah? All right, now listen. I'm going to show you another trick here. Not trick. Another method for doing this that some people prefer. I don't, but other people do. And it's perfectly legitimate. Isn't this the cubed root of 16 times 54? And isn't that the cubed root of 2 to the 5th right? Times, times 2 times 3 to the third. Isn't it? 2 times 3 to the third is 54, yeah? Oh, it's not 2 to the fourth. It's 2 to the fourth, sorry. Not 2 to the fifth. But everybody's cool? Now, 2 to the fourth and a 2 gives us what? 2 to the fifth times 3 to the third, right? I'm looking for groups of 3, yeah? So I can get out a 2, I can get out a 3, and I left 2 squared under there. 2 times 3, 6 cubed root 4. You'll get the same answer. Do I care what you do? No. You have to decide what works for you. It's totally up to you. I work with whatever works best for me on the question. Right? When I look at this, I don't see that as 16. I see that as 2 to the fourth when I'm doing radicals. Because I've taken the time to memorize the 2. Remember I told you it's a good idea to memorize the 2 and the 3? I have. You, of course, haven't. That's okay. Because you can still get the answer. Now, what are you going to do with G? You're not going to tell me that it is, I can't even do that one in my head. You are not going to tell me that that is 15 root 1,764 and start factor treeing that, are you? Of course not. What are you going to do? You're going to simplify now. What is this? 4 times 7, so it's 10 root 7. What's this? 9 times 7, so it's times 3 root 7, yeah? What's 10 times 3? What's 7 times 7? Root 49. What is the root of 49? Oh, yeah, because there's 3 out front. Thank you. What's 10 times 9? 90. Root 49? 7. What's 90 times 7? 630. Yeah? Now, can we forget any of our previous math? No. All math rules apply all the time. Look here. Doesn't that look a lot like 2x plus 3y times 2x minus 3y? And we would do FOIL, correct? So what are we going to do here? FOIL. We're going to take this first one and we're going to multiply it by what and what? That one, then that one. What is 2 times 2? What is 8 times 3? Root 24. Minus, what is 2 times 3? 6. What is 8 times 2? Then, what are we going to do with that guy? The same thing. What is 3 times 2? 6 root. What is 7 times 3? What is 3 times 3? And what is 7 times 2? And all the multiplying is done. What's the only thing left? Simplify if possible. Can I simplify that? 4 times 6. So what is it? 8 root 6. Minus, what's that? 24. Because 16, square root of 16 is 4. What's that? Stays the same. Why? No pairs. 3 times 7. What's that? Stays the same. Why? No pairs. 2 times 7. Gouda? Now, just out of curiosity, Do you think that this is written in the order math guys would like? What should I do? First of all, do I care? Can I guarantee other teachers won't care? No. So what should you be aware of here? What do you think is the order we should write this in? Ken? Radicals first? I agree. Which radical first? Again, this doesn't matter. I'm just out of curiosity because some teachers care about stuff like this. Colin? You think you should put the -9 first? Why?
Because it has the largest coefficient.
Yeah, okay, that's perfectly fine. Makes good sense. It's actually the smallest coefficient, right? Because -9. So we'd start at the negatives and move our way up. Yeah? Good sense? Maybe it'd be okay. But, weirdly, math guys, if they can avoid it, they don't like a negative at the front of a polynomial. So they would probably 6 root 21 plus 8, minus 9 root 14 plus 8 root 6 minus 24. Because they would go down in descending radicals. Again, I don't care. I couldn't care less. Can everybody multiply? Okay. Let's practice a little. Turn the page over. You have a blank page there. There are 2 questions. Try them. It's 3 root 24 times 2 root 48 times 4 root 56. Come on, man. That's obviously a 5. Right there. That's 56.
Yeah.
Oh, okay.
Okay.
I thought you were saying you couldn't read it.
No. I was just simplifying the first one.
Oh, I see. Okay. Everybody cool with the first one? Numbers are just big, right? Don't change our rules. Just do our multiplying. If you have trouble multiplying 6 times 384 in your head, where do you go? To your calculator. Easy peasy, right? Now, what is it about the second example that freaks you out? Fractions. But it's nothing worth freaking out about, is it? What do you do with those? To get what? Negative 14 root. What do you do with those? Multiply them. 6 over 35 times 5 over 9. And you just multiply. But you should be able to notice that 5 and 35 do some canceling, don't they? How many 5s fit into 5? How many 5s fit into 35? 7. Anything work with 6 and 9? 3. How many 3s fit into 6? 2. How many 3s fit into 9? 3. What's 2 times 1? What's 7 times 3? So I got negative 14 root, what? 2 over 21, right? Now, we've already talked about what that really means, yes? It really means negative 14 root 2 over root 21. And there, damn it, there is what we're going to do in the second half of today. We're going to talk about how to deal with that. That's as far as you can go with that one. Everybody cool? All right. Now, being the intelligent young people that you are, what do you think is going to happen here now that I have variables? That's really impossible to read, idiot. What am I going to do now that I have variables in there? Is anything going to change? No. Could I simplify now? Oh, it's got the answer there. Okay, so we would do 3 times 6 to get 18, right? Right? And then 8 times 12 to get 96. X to the third times x squared to get x to the fifth. Y to the fourth times y to the ninth to get y to the 13th. What would we do there now? Simplify, because that is, I use a different color. That's a stupid color. 16 times 6. X squared, x. I don't even want to write that out that way. What's coming out? What's 4 times 18? 72. How many x's are coming out of there? 2. How many y's? 6. What did I leave under there?
1 y.
Eckham. I left the 6. How many x's? 1. How many y's? 1. Everybody good? Okay. This becomes a problem now. Why are you not good? You all told me you had no problem with 3 times 6. Right? We've also done exponents. So you should have no problem with 8 times 12 to get the 96. X cubed times x squared gets me x to the fifth. Because of exponent laws. I know it's blue. And then y and y gets me y to the 13th. So every single one of you should be able to get here without thinking. Okay. Then you're doing what we do now. 96 breaks down like always. X to the fifth means there's 5 x's under there. I'm looking for groups of 2. So I have x times x times x times x times x. There's a group of 2. so out comes a single x. There's a group of 2, so out comes a second x. X times x gets me x squared. I left an x. Why? I'm not going to write out 13 y's. So I'm going to do what it actually is happening. I divide that by 2 to get y to the 6th with 1 remainder. Okay? Everybody good? Okay, prove it. Do that one, and then we're done with these. Is there something you could do before you try to multiply 4 times 2 at 40 times 250? Should we simplify at the end, the beginning? When? Always. Is 40 and 250 big enough numbers to consider simplifying? I would. What's 40 break down into? Why would I not use 4 and 10 in this question? Because it's a cube root, so what would I use instead? 8 and 5. What's the cube root of 8? 2, so that comes out here, and what do I get? 12. Can I get any x's out of here? How many? 1. Did I leave any x's under there? Can I get any y's out? No. So what did I leave under there? 5y squared. Agreed? What's 250? I would use 125 times 2. Why? 125's got a cube root. What is it? 5. So what's coming out? 5 times 8, which is what? 40. Can I get out any x's? No. Can I get out any y's? How many? 1. What did I leave under there? 2 x y. Now let's do our math. 40 times 12. What's 4 times 12? 48 with the 0. 480. X times y. What is it? xy. Cube root. What's 5 times 2? It's not a trick question. 10. And what's y squared? I love it when I do that when we're in the middle of hard math and I give you guys like, what's 5 times 2? And everyone's like, and then I hear it whispered like 6 times, 10. I think it's 10. I don't want to say it because I'm not sure, but I think it's 10. Ladies and gentlemen, when you're in 8th year calculus, 5 times 2 will still be 10. Okay? You don't need to, stuff like that doesn't change. Okay? So, again, what's x times nothing? X, and what's y squared times y? Y cubed. Could we stop there? Why not? Why not? Because the 3 y's, I can bring out another y, but I already have a y there, so it's 480x y squared cube root 10x. And that is about the hardest multiplication question I can really give you. That's hard to read. 480xy squared. Cube root 10x. Is everybody cool with multiplying? Now, we left a hole there, right? That's what we're moving on to right now. Right meow. Don't look. You're not supposed to see that yet. I forgot to delete last semester's notes. What a dummy. Now, ladies and gentlemen, I am aware that I'm throwing a lot at you at once here, but I'm doing this on purpose because these two are so closely related that I want to give them both to you at once, and then I'll give you tomorrow to practice with both of them. So you'll have no homework tonight. Okay. It's similar to multiplying in that the index numbers must still be the same. Okay? So if I gave you this, what's the answer? 3, right? 6 divided by 2 is 3. So if I gave you this, 6x over 2x, what would the answer be? 3 again. If I gave you this, 6x squared over 2x, what would the answer be? 3x. Everybody's cool? Okay. So now logically, again, if I gave you 6x squared y over 2x, what would the answer be? 3xy. Everyone's cool, yeah? So, logically, again, and I use the word often, what logically is this answer? Three root 2. And now you know how to divide fractions. So what is this answer? Square root 6. I'm not joking. Are you guys missing the x there like I am? Yeah. So put it in. Okay. Logic. Math is logical. It follows patterns. What are you going to do with fitting in 3? To get 5 root. What are you going to do with fitting in 3? Divide to get what? 5. What are you going to do with x cubed and x? Divide to get what? X squared. What are you going to do with y squared and y? Divide to get y. Would you leave that? Would you leave that? The x comes out. Why? Because there's 2 of them. So what's the answer? Easy peasy. Right? Okay. You can all do that? If I write one more here, you'll be able to figure it out? You tell me that answer, just to make sure. Everyone is good? Okay. Here's where the weird thing happens. The nature of radicals. Okay? We cannot have a radical in a denominator because it makes no sense. You can't divide by something that is an endless division. Everybody cool? So we have to undergo a process that is called, we must rationalize the denominator. All right? And this is achieved, and I'm going to highlight that sentence, or that term. This is achieved by remember when we were multiplying, we discovered that if we take the root of x and we multiply it by the root of x, we end up with x. We got rid of the radicals. So knowing what you know without doing anything fancy, if I told you my answer came out to this, 6 over root x, is that allowed? No. What part of that isn't? The root x. So how do I get rid of that? I multiply by another radical to eliminate that radical. Well, obviously that radical is going to be root x, yes? But if I don't put something there, is this going to be the same? No, I must multiply by 1 to keep this value. We all understand that that value is 1, correct? So even though it will change the looks of this, it does not change the value because this is only 1. Everybody cool? So what does my answer become? 6 root x over... No. X, root x times root x is x. And now we're done. Because if I told you what the value of x was, this would make sense, right? If I told you x equaled 2, this answer would be 3 root x, right? And that would make sense. Everybody cool? All right. Now, is it possible, everybody highlight the word conjugate. X plus y conjugate is x. The conjugate is x minus y. All right? So, what is the conjugate here? Root 17 plus 3 root 14. What's the conjugate here? Root 34 minus 4 root 2. Conjugate there? Just root 5. Okay, I'm about to tell you why. Conjugates eliminate radicals. And here is why it works. If I do x plus y times x minus y, what do I get? X times x is what? X squared. What's x times negative y? Negative xy. What's y times x? Positive xy. And what's y times y? Minus y squared. What happened to the x and y's? They disappear. Everybody understand? So logically, what would happen if I had the square root of I know it's blue, don't worry. Is that allowed? No, because there's radicals in the denominator, right? So I got to get rid of them. So I know I got to multiply by root 17 to get rid of root 17. And I know I got to multiply by 3 root 14 to get a 3 root 14. But if I don't make it negative, are the middle terms going to drop out? And in this case, wouldn't those middle terms be radicals? And that's what I'm trying to get rid of. So I have to do a negative there. Which gets me for an answer, 17. And then I know the middle terms are dropping out, yes? Minus 3 times what's root 14 times root 14? 14. So my denominator becomes 17 minus 42. Everybody cool? You already know why conjugates work, because you know how to do FOIL. And now you know that you have to use a conjugate if you have more than one radical, or those radicals won't disappear. And what's our goal? To make the radicals disappear. Everybody cool? Let's try. We'll build up like we always do. How will I get rid? Is this allowed? No. What do I need to get rid of? 3 root 7, correct? So, what is the only thing I am trying to eliminate here? Am I trying to eliminate the 3 or the root 7? Root 7. So since I only need to get rid of the root 7, I only need to multiply by root 7 if there's one of them, correct? So what does this numerator become? 2 root what? 42 from our last lesson, right? Over 3 root what? 3 root 49, which is 2 root 42 over what is 3 times the root of 49? 21. Is my radical out of the denominator? So am I okay? I am. Now some of you will think you won't have been paying attention and you'll see 42 on the top of a fraction, 21 on the bottom of a fraction, and think you should simplify there, right? Can you? Why not? Because one's a radical. It's got a different base. Everybody cool? All right, let's look at this one. What am I trying to eliminate down there? Just the root 6. So do I need to multiply by 14? No. I'm going to multiply by root 6 over root 6, which is really what value? 1. So I'm not changing anything, am I? So what do I get in the numerator? 7 root 30 over 14. Now, remember, I'm actually writing it out because I'm the math teacher. 14 root 36. Which is, we know is 6, right? So we know it's going to be 14 times 6 on the bottom, which is 84. So I've got 7 root 30 over 84. Can that simplify? Yes, why? 7 goes into 7 once, root 30, and it goes into 84 12 times. Everybody cool? What I did there was I took 7 84ths and I simplified it to 1/12. Everyone's cool? Now, just like when we're multiplying, when the numbers get bigger, what should we do? Simplify. So do we have bigger numbers in C? So we better simplify. What is 50? 25 times 2. What's coming out? 5. So I've got 30 root 2. Agreed? Over. What's 18? 9 times 2. So what's coming out? So I've got 15 root what? 2. What's 30 divided by 15? 2. What's root 2 divided by root 2? It's 1, isn't it? So there's no radical in the denominator, so we're done. Everybody cool? What are you going to do with D? What's 60 become? I would do 4 and 15 to get 6 root 15. This is 9 times 3 to get 6 root 3. Now, we're bothered by this, but we try to simplify. Does 6 divide by 6? They cancel. What's 15 divided by 3? Root 5. Do I have anything in the denominator? So are we okay? Sure we are. What's weird in E? There's 2 in the numerator, 1 in the denominator. What of those 3 bother us? Just the denominator. So what would I multiply by? Root 3 over root 3, which will give us over root 9, right? What is the root of 9? 3, so we're cool. Now what do I have to do up here? If that wasn't there, what would it be? 6 root 6. If that wasn't there, what would it be? Minus root 9. So since they're both there, what did we actually do? We just distributed. And I get 6 root 6 minus 3 over 3. Now some of you are going to say, oh, I'm going to cancel. Can you? No, because this is a binomial. Everybody cool? But some of you will then say, but Mr. Myers, isn't that 6 root 6 over 3 minus 3 over 3? Yes. What is 6 divided by 3? 2 root 6 minus, what's 3 divided by 3? 1. So that is the finished answer. But some of you will try to have done that and told me that is the finished answer. Does everybody understand? Do you think I'm happy if you get to there? Yeah. But you want to know how to get to the end. Everybody cool? All right, now, this is the hardest of the singles right now. What bothers me here? Root 2. So what do I multiply by? Root 2 over root 2. You guys try to do that one right now. When you think you have it, subtly tug on your right ear. This is a test for how many people know what subtle means and how many people can tell left and rights. Usually when I do that, I say subtly tug on your right ear. And the class mirrors me and starts pulling on their left ear. Because you remember elementary school when your teacher went like this. And you went. And you mirrored her. Or him. Good times. Now, I saw a lot of ear tugging. What is the answer? What is the answer? He waited patiently. Are you let's going here?
You made me erase my right answer.
Ooh, shame. Is everybody good? Now, please notice, yet again, we are bringing nothing new to this party, are we? Everything we are doing goes back to your very first lessons in math, right? Is everybody cool? You all understand why this is not root 3, right? Because there's two different bases, so I can't divide them. Is everyone Eckham?
How did you get from 2 root 6 over 4 root 6 over 2?
Well, what's 2 over 4?
1 over 2. Oh.
1 over 2. Everybody good? All right. What's different here?
There's 2 on the bottom.
There's 2 of them, so I got to eliminate them, right? So I know I got to multiply by root 15 and root 10. But what do I have to do to ensure that the middle drops out? I have to use the conjugate. So what do I got to multiply up here? Same thing, because I have to multiply by 1, right? What's root 7 times root 15? It's root 105. It's cool. Plus root 70 over, what's going to happen? Root 15 times root 15 is what? 15. Minus root 10 times root 10 is what? 10. So I got root 105 plus root 70 over 5. Am I done? No, because I might be able to simplify. I can't simplify 105, can I? Because it's 3 times 7 times 5. No simplifying there. Can I simplify that? It's 2 times 5 times 7. So I can't simplify that. So am I done? Yes. Everybody cool? All right, you are intelligent young people. This is the last thing I'm getting you to do today, and then you're getting a break from everything, so you're not going to do any more work till tomorrow. What is my multiplier here?
2 root 3 plus
2 root 3 minus root 2 over? Same thing. Why does it have to be the same thing, Eckham? So they cancel out at the bottom, and so this value doesn't change, because what does this equal? 1. Now, why is this is this any harder? No, it's just 2 more multiplications, right? It's just FOIL with radicals. Go slow. What is that one? 6 root 6. Okay. What is that one? Minus 3 root 4. Agreed? Now I go to the other one. What is this one? Plus 2 root 9. And this one. Minus root 6. Over, the bottom's easy. You know the shortcut now. What's 2 times 2? 4. 3 times 3? Root 9. Minus root, what's 2 times 2? Root 4. Now simplify. Are there anything I can do in the numerator? You see a root 4 and a root 9, don't you? And you see a root 6, take away root 6. So what is 6 root 6, take away 1 root 6? 5 root 6. What is the square root of 4? 2. So that is negative 6, isn't it? What is the square root of 9? 3. What's 2 times 3? So that's positive root 6, isn't it? So what happened there? They disappeared anyway. So I got 5 root 6 over, what's the square root of 9? What's 4 times 3? 12. Minus, what's the square root of 4? 2. 5 root 6 over 10. Am I done? Am I done?
No.
What is the answer?
Root 6 over 2.
Root 6 over 2. And ladies and gentlemen, believe it or not, that's pretty much as hard as it gets. So if you can follow that, you're good. Now, you worked beautifully today. You get the night off. Tomorrow is going to be a work period on this stuff. Now, listen please. You don't have to write anything more, but I would like you to listen. Please notice that rationalizing denominators automatically practices the multiplying, right? So I'm not going to do a lot of specific multiplication practice, okay? Because the dividing will cover that. Everyone is good? All right. You got 7 minutes now, and you got a whole night off.